Okay, this is the distance and midpoint Cornell notes. So in the previous video, we were talking about segments and segment addition postulate, things like that. Now we're going to talk about how to basically apply that to a coordinate plane. So we did discuss midpoint being the middle point. So that would be a point that is exactly in the middle. Let's change that. Okay, in the middle of two endpoints of a segment. Okay, so again, that is midpoint. When finding the midpoint between 2 points, not only are you finding the middle, but you're also finding the average. All right, so midpoint from 2 coordinates. So again, like I told you before, we are now using coordinate planes in this particular lesson. So the midpoint between 2 points with these coordinates, we use this formula. Very important formula. If you're in class, you'll see it on the wall. If you're not in class, you need to write this down somewhere because it is very important. All right, so we've already talked about how to label points like this. That's nothing new. The x1 and the y1, the x2, the y2. So let's get into an example. Segment AB has endpoints A and B. Find the midpoint of the segment. Okay, so first I'm going to graph it. -1 and up to, so that's point A. And then we have 5, 1. Let me use different colors as usual. And boom, there's point B. Now, to be very honest, you could count and find the midpoint. So you could say, okay, I see 1, 2, 3, 4, 5, 6. 6, like a horizontal distance would be 6, just a horizontal distance. So you could say, okay, well, I'll just go over 1, 2, 3. So if I connect these two in a line, and then I go over 1, 2, 3, and then I go down until I hit the line, this would be the midpoint. I don't know if that made any sense, but it's okay. A lot of people don't get that concept, but a lot of people do, and they really like it. If you are liking the graphing method, then you can definitely use that. However, it's not foolproof, so let's look at the formula. All right, so I'm going to rewrite the formula as usual. Notice that we're using a capital M and not a lowercase m. Don't forget lowercase m is slope. Capital M is midpoint. Okay, so you already know what's good. Let me go ahead and use my erase and replace method. Okay, so I'm going to erase x1 and y1 with -1 for x1 and 2 for y1. And then for x2 and y2, I'm going to replace those with 5 and 1. So x2 is 5, y2 is 1. And you see that's what we have. So the midpoint, again, we're using a capital M. If you want to type this in your calculator, that's totally fine, but that's going to be +4/2, which is just 2. And then 2 + 1 is 3, divided by 2 is 1.5. Let's compare that to how our graph looked. So I'm going to use my yellow highlighter here because this is the same thing we should have gotten on the graph. So if I look over here, let me just zoom in. I see that the coordinates are 2 and then 1.5. I had to go up 2, so that checks out. So like I said, you can use the graph or you can use the formula or both. Both are great. All right, the next topic, finding an endpoint given one endpoint in the midpoint. Okay, this is where people start scratching their heads, and honestly, this is where if you're a grapher, like if you're good at graphing, this is where it's gonna really come in handy. Okay, so first let's go ahead and graph these 2 points. So first I see B and then A. Oh, just kidding, C, sorry about that. Is here, and then we don't know where A is. So for A, I'm just going to use yellow. Okay, so let me go ahead and graph the points that I do know. So B is at -1, oops, sorry. 6. Okay, so we have -1 up 6 right there. And I'm not gonna lie, I'm having a hard time seeing the axes. Give me a moment. I'm gonna kind of make them a little bit easier to see. Oof, that was way too much. Hold on, let me make that a little bit more narrow. There we go. Okay, that helps me a little bit. All right, and that was again point B. Now let's look for point C, which is at 2, 8. Okay, there we are right there. Okay, cool beans. And it says B is the midpoint. So if B is the midpoint, let's see where we can find A. All right, so B is the midpoint, which means the line is not going to go that way, right? Because this one has to be in the middle. So the line has to go that way, and then A is going to be somewhere over here. So let's see if we can use slope, actually, to figure that out. So let's see, what's the pattern here? We go down 2, so down 2, and we go 1, 2, 3 to the left. So we go to the left 3. Let's do that same pattern. Down 2, 1, 2, and then we go to the left 3. 1, 2, 3, and then there it is. There is point A, and that's honestly how you can use graphing to keep that. To find that, sorry. All right, so I'm going to connect these 3 points, and then we're going to try it the algebraic way. So that was the graphing way. Now we're going to try it the algebraic way. All right. Oh, and what are the coordinates of A? Because we want to make sure we got it right when we do it the algebraic way. That's -4, 4. Okay, so let's see if we get that. So I'm going to start with the midpoint formula yet again. Capital M, x1 plus x2 over 2, y1 plus y2 over 2. All right. Okay, so I set up my formula. Now, here's the problem. It says that B is the midpoint. So when I'm erasing and replacing, I'm going to put B over here, which was -1 and 6. Then I'm going to replace C with, this x1 and this y1. So that's going to be a 2 and an 8. So I'm going to make that x1, y1. But again, we can't make the B be the other one because this is the midpoint. Okay, now here's where it gets weird. Well, if it's not already weird to you. The x is going to equal this. So I'm going to set that up right now. -1 equals 2 plus x2 over 2. Cool. Now the y is going to equal this. So that's going to be 6 equals 8 plus y2 over 2. And now we're just going to have to solve both of those. So as you can tell, it's a bit much. I'll keep going just because I feel like I should, but it's a bit much. All right, so the first thing I need to do over here is multiply both sides by 2. I don't know if you guys remember from when we did algebraic proofs, but to get rid of a fraction, you just get rid of the denominator by multiplying both sides by the denominator. So that's going to give me -2 equals 2 plus x2. All right, cool. So now I'm going to subtract, 2 from both sides so I can get rid of that. That's going to be -4 equals x2. Okay, so that's one of my coordinates. Let's keep going over here. Y'all probably like, Miss E, this is too much. Honey, that's why I don't do it this way. That's why I graph it. That's why I graph it. All right, now the same thing over here. I'm going to multiply both sides by 2 so I can get rid of this denominator back. And then I'm left with 12 on the left of the equal sign and then 8 plus y2 because I got rid of that denominator, so now it's gone. Oops, not y squared, y2. Okay, now I'm going to take away 8 from both sides, and that's going to leave me with 4 is y2. So when I did it this way, I got x was -4, y was 4. Isn't that the same thing I got up here? And you see how much longer it took me when I did it that way? So, yeah, if you can graph it, honey, just graph it. Example 3. A is the midpoint of CT, A is at negative 26, and he is at negative 4, 2. And this one says do it without graphing. Oh no, what are we going to do? We'll be all right. So do it without using a graph. We got this. All right, let's set her up. So we have capital M, don't forget, equals x1 plus x2 over 2, y1 plus y2 over 2, and let's get down and dirty with it. Okay, so the first thing I need to do is kind of identify what's going on here. Let's do that because this is a whole mess. All right, first it says A is the midpoint of CT, and then over here it actually tells us what A is. So A is, okay. So since A is the midpoint, we're gonna go ahead and put that over here because that's what the capital M is for, it's for midpoint. So put the midpoint where it goes, okay? After you do that, it says T is negative 4, 2. So, just gonna highlight that for my own vision purposes, I guess. Okay, so, and I guess, well, I'll just erase and replace. Save myself a little trouble. Okay, so that goes there. Okay, so I'm gonna go ahead and erase x1 and, I'm gonna do that, and y1, and we're gonna replace that with these up here, so x1, y1. All right, so that's gonna be my negative 4, that's gonna be my 2. And I accidentally erased the other part of this plus sign. There we go. Okay, so like I said before, separate it into x's and y's. So I'm gonna separate this one to the x. So negative 20 equals negative 4 plus x2 over 2. And then draw a little dividing line there. Then over here, we have 16 equals 2 plus y2 over 2. Oop, not all of that, just this, over 2. Okay, so I took these two coordinates and I put one right here and I put the other one right there. All right, now we need to solve it. Just like before, multiply both sides by 2. That has not changed. So we can get rid of that 2, and then we multiply by 2 over here. So that's going to give us negative 40 equals negative 4 plus x2. And we're going to add 4 so we can get that x by itself. And when I say x2, it just means it's the second x. The 2 is only telling you which x it is. It doesn't actually do anything. Anyway, that's going to be negative 36 equals x2. All right, so that's the first one we need. Same thing over here. Multiply both sides by 2. Okay. All right, so that's going to cancel out my 2's, giving me 32, right? Because 2 times 16 is 32. Yeah. And then 2 plus the second y, or y2. Okay, and now we're going to take away 2 from both sides, leaving us with 30. Those cancel, equals y2. So the y coordinate is 30. So as you can see, these numbers are rather large and in charge. So it's easier probably not to graph these despite all this work. I know. And that was point, what was this point called? C. So this was point C. Hold on, let me move this box out the way. So that's